new check engine light. So I'll give you a new check engine light. Oh. Hello there. Don't mind this. It's a little frustration. Project Ute seems to find new check engine lights every day. So instead of hitting it with an axe, I'm going to bring you some of the 3D printing content I've been promising. Welcome to 3D Printing Basics. How's it going, everybody? Welcome to Make It and Break It. My name's Andrew, and on this channel we take motorsports projects and car builds, motorcycle builds, whatever, and we run them through the entire process for you. From designing it, to building it, to sending it on a racetrack, or adventure, or whatever sounds cool at the time. Today we're going to take a break from our 300U to RX-8 Doritos Locos project and everything else we're working on, and do some of the 3D printing stuff I've been promising. And we're starting with our 3D Printing Basics series. So the concept here, as I go through a bunch of this stuff back where it sort of belongs, is we're gonna walk through some of the basics of 3D printing. And that's maybe a slightly wrong term to use. Some of the basics of 3D printing and what it is, what it can do, how you can use it in your garage or in your home workshop or something like that. I think this goes down here. And try and show you guys a little bit of how you can take advantage of some of this cool technology that's now actually very affordable. Get this crap off. So the first thing I want to cover is what is 3D printing. 3D printing is a subset of manufacturing processes in an area or region of the industry called additive manufacturing. So manufacturing is just making something from your smaller base materials, right? And most manufacturing that everyone's familiar with, things like mills, lathes, all the really cool CNC heads that drill out holes and things like that, that's all subtractive manufacturing. And the idea is you build your final form by subtracting material from the initial starting material. And you use this in your garage a lot of times with things like a grinder. So you use a grinder to cut tubing or cut plate, something like that. Grinders are a handheld form of subtractive manufacturing. Additive manufacturing works pretty much the opposite. Where did these freaking gloves go? They go over here. Additive manufacturing takes the base material and builds it up, typically in a layer form because that's the easiest way for us to process it, and allows you to, instead of subtracting from a big block, you add from a lot of smaller pieces into one bigger thing, essentially. So additive manufacturing can take a lot of forms past that. 3D printing is one version of that, and back over here underneath that grinder is my awesome new 3D printer. I'm gonna start featuring that on the channel a little bit. I might show you guys some stuff I do for some commission projects I have coming up. But 3D printing is one type of thing. There's other manufacturing processes that are additive based that aren't really traditional 3D printing. So what is 3D printing? It's an additive manufacturing process that takes a 3D model from your computer, from a 3D scan, which is really cool, somehow a 3D file on a computer, and builds it additively. So usually it adds some sort of substrate. There's a lot of different styles. Usually they build it in layers, but that's not always the case, especially with some newer types of 3D printers. But there are some main types that you'll probably see in your home garage. One of the most common types you'll see and probably use, to be honest, even myself, my old engineering job, we only really used one style of 3D printing, is called fused deposition modeling, which is the old Stratasys patent term. You'll also see it as fused filament fabrication. What it is, it's a machine that takes plastic from a filament roll, like this thing over here, runs it into a head that has an end that melts that plastic, and deposits it on a build plate. So that's this thing down here. And this head will move around, and it's controlled by a computer file that is run in the machine. So that's an FDM style printer, and those come in many different shapes, sizes, and varieties. From the simplest one, like this Monoprice Select Mini V2, which I've shown on the channel before and will still probably use a lot because it's a very accessible printer. It's less than $200 and it's fairly capable in certain materials. To something like this. This is my Raise 3D Pro 2 Plus. This thing is ridiculous. It's prosumer, industrial level printer, and it's probably one of the bigger ones that you'll see. And this one has a lot of other features that I can go over in another video that are really let it print in a lot more materials. These are both FDM style printers, which is probably the printing that you've seen most often if you've been looking into 3D printing. There are other style printers, which I don't have on hand, but I'll cover here for a second. So there's another style printer that's fairly common now. It's starting to get more accessible. It's called SLA printing. There's also DLP printing, which is a little bit cheaper and it works slightly differently, but it's essentially the same way. And that works by bouncing a light or a laser, or in DLP printing it just bounces light into a bowl of resin. And I'll try and show some pictures of this, overload some pictures here. And then it cures it onto a build plate and builds it up, which gives you some capabilities for clear parts that are not necessarily capable in these FDM style printers. It gives you capabilities for much more smooth or detailed parts, so things like logos can print a lot smoother on those things. But it also comes with the downsides, like its printing material is a resin that you have to keep out of the sun and out of light so it doesn't cure on you. It's not as easily accessible as something like these FDM style printers. SLA is really cool and it's starting to get accessible. SLA has some definite uses in an automotive application. Obviously this one does too. Another printer you might start seeing in the more mainstream office, small workshop type environment. Not in big manufacturers have been using this sort of stuff for years, and even more expensive things, is an SLS, so selective laser sintering. And it's essentially a laser, legitimately a laser, that gets directed by mirrors around a build volume over a layer of, in most cases, nylon. And the nylon is then melted together into a part, and then the machine puts another very small, very thin layer of nylon over top, and the laser comes back and melts layers and layers and layers and builds itself up. Really cool, can do internal voids really well, does really cool. It doesn't need support material, which is a drawback of FDM and even SLA and DLP styles. You need to support the material with some extra material you have to cut, and adds post-processing time. But SLSs really don't have that problems. So there's some cool stuff there, but they are expensive. Their build volumes are typically small, especially in the enthusiast prosumer level of build volumes. And there's a lot of, you're just dealing with a lot of fine plastic particles, which means processing and handling them can be a pain. So there's some benefits and drawbacks. And then going outside of that, additive manufacturing also is now starting to mainstream metal additive manufacturing. Metal additive manufacturing has a ton of processes, from electron beam additive manufacturing to something that looks a lot like this. In fact, it uses fairly similar technology to a fused deposition modeling type printer. It just prints a filament that is enough plastic to hold it together, and then everything else is metal. And then there's post-processing after that, where you burn out the plastic and then heat the metal enough so that all the pieces kind of come together, and all the little spheres that essentially make up the metal in that filament melt together, and sinter is the term there. There's other things that look like a weld head, and they build really cool things with that. But the metal machines are typically out of the reach of your garage level guy. Like this machine's $200. This machine's pretty capable on everything except super engineering plastic, and this thing's only $6,000, and it's got a very large build volume. A metal desktop 3D printer that prints in roughly this size, give or take, will cost you $120,000. right? So it's not like it's just something you should expect to see on everyone's desktop. Yet. Pretty soon. These 3D printers used to be quite expensive too. This isn't like a whole pluses and negatives on all the different types of 3D printing. I just want to give you guys a scope of what's out there in terms of stuff that you probably will see and you should be using. Actually, this is really good stuff if you have the few items you need to support it. But if you're curious or you need someone to build you something really unique, there are companies out there that can build things in metal, build things in some very cool engineering plastics that are functional pieces. So this has been our first installment of our 3D Printing Basics series. These are not intended to be the end-all, be-all of 3D printing instruction. This is basically just a starter for you to then go out into the world and look into different things. If you have questions about 3D printing, what it needs, what types of 3D printing are useful for your application, what materials, some of that will get covered later on in this series. But we're trying to keep these videos short and to the point so that we can get a bunch of information out there quickly. Next episode will probably cover getting started in 3D printing and what you need. As always, guys, like, comment, subscribe, do the YouTube thing. If you have questions about 3D printing, definitely throw them in the comment section down below. I'll answer them there. And if we get enough questions about a certain subject, I'll create a 3D Printing Basics video on that. So, my name's Andrew. This has been another Make It and Break It YouTube video. Thanks for watching. And don't forget, the one basic question you need to answer about your project is, why not build it? I'll catch you guys later. Oh gosh. Nearly died.